What if the universe started from nothing, and nothing is what it will return to? Now, this might sound like the plot of a sci-fi novel, but it's actually a concept that scientists have been grappling with for years. Let's dive into the deep, dark, and infinitely fascinating mystery of the universe. Imagine the universe as a giant balloon. Around 14 billion years ago, this balloon was infinitesimally small. It was a point of singularity, a place of infinite density and gravity. Then, in a split second, it expanded rapidly. This is what we call the Big Bang, the birth of the universe. But unlike a balloon popping, the universe didn't just stop expanding. It's still growing even today. Now you might be wondering, what's fueling this cosmic expansion? That's where the concept of entropy comes in. Entropy is a measure of disorder or randomness. As time moves forward, the universe becomes more and more chaotic. Energy spreads out and stars burn out. It's like a cosmic game of musical chairs, where the music is the energy and the chairs are stars. Eventually the music will stop and there'll be no chairs left. This leads us to the unsettling idea of the universe's potential end, often referred to as the heat death of the universe. This is not a fiery inferno, as the name might suggest, but rather a state of maximum entropy, where all energy is evenly spread out and there's no place left for any work to be done. In this scenario, the universe would become a vast, cold, dark place, essentially returning to nothingness. So, it seems that the universe might be on a journey from nothingness to nothingness, with a whole lot of cosmic drama in between. The birth, life, and potential death of the universe are all part of the grand cosmic dance. It's a dance that has been going on for billions of years and will continue for billions more. So, in the grand cosmic dance, we might end just as we began, from nothing. Imagine for a moment a time when the stars were nothing more than distant points of light, unreachable and untouchable. That was our reality, not so long ago. Until the dawn of the space age, a period that changed the course of human history and our understanding of the universe forever. In the mid-20th century, the space age was ushered in with a bang, or rather, a blast-off. The first missions to space, spearheaded by pioneering nations, were like nothing we had ever seen before. The spacecraft, the astronaut suits, the fiery ascents into the stratosphere, it was all so new, so daring, so exciting. These missions, while thrilling to watch, held a purpose far greater than spectacle. They represented the first steps in a long journey of exploration and discovery. With each mission, we ventured further, learned more, and dared to dream bigger. The stars, once distant and untouchable, were suddenly within our reach. The importance of satellites and space probes cannot be overstated in this grand narrative. These technological marvels, sent into the cosmos carrying the hopes and dreams of humanity, have been instrumental in gathering invaluable data about our universe. Through their eyes, we've seen the swirling storms of Jupiter, the icy rings of Saturn, and the fiery surface of our Sun. The data collected by these satellites and probes has not only expanded our knowledge of the cosmos, but has also fundamentally changed our understanding of our place within it. We have discovered that we are but a tiny speck in a vast, ever-expanding universe. A humbling realization indeed. But the space age has done more than just humble us. It has inspired us. It has shown us that the impossible is possible, that the unreachable can be reached. It has sparked a thirst for knowledge, a yearning for exploration, and a drive for innovation that continues to push the boundaries of what we thought we could achieve. And so, the twinkling stars became destinations holding promise for the future. Have you ever looked up at the night sky and wondered if we're alone in the universe? What if I told you that our universe, with its 100 billion galaxies, each containing hundreds of billions of stars, might be teeming with life beyond our wildest imaginations? That's right. We're talking about alien life. Alien life, as we imagine it, doesn't necessarily mean little green men or creatures with tentacles. It could be as simple as microbial life forms or as complex as civilizations far advanced than ours. The universe is so vast and diverse that the possibilities are endless. Now you might be thinking, if there are so many possibilities, why haven't we found any evidence yet? That's where the Fermi paradox comes in. Named after physicist Enrico Fermi, it's the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. To make sense of this paradox, we use something known as the Drake equation. It's a formula that attempts to estimate the number of advanced civilizations in our galaxy. The equation takes into account factors like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. While the Drake equation gives us a sense of optimism, we're still left with the big question: where is everybody? This is where SETI, the search for extraterrestrial intelligence, comes in. SETI is an ongoing scientific effort to detect signals from alien civilizations. In addition, space missions like those to Mars have been trying to find evidence of past or present life. The recent discovery of water on Mars has bolstered the hopes of finding microbial life there. So, the search continues. It's a search not just for answers, but for a greater understanding of our place in the universe. It's a search that pushes the boundaries of our knowledge and our imaginations. So the search continues. Perhaps one day, the stars will answer back. What if the stories we tell could shape the future we build? Science fiction, often dismissed as mere flights of fancy, has repeatedly demonstrated its profound influence on real-world science and technology. It's a genre that pushes the boundaries of our understanding, venturing beyond what we currently know or believe to be possible. It prompts us to ask, what if? Take Star Trek, for instance. This iconic television series introduced us to a handheld device called the communicator. Sound familiar? That's because it bears a striking resemblance to today's cell phones. The show's creators might not have realized it at the time, but they were predicting a future where wireless communication devices would be commonplace. Another example is Arthur C. Clarke, a science fiction writer and futurist who conceptualized geostationary satellites long before they became a reality. His writings sparked the idea of satellites that could remain in a fixed position relative to the Earth's surface, revolutionizing telecommunications and weather forecasting. But it's not just gadgets and machines. Science fiction also influences our views on broader scientific concepts, from artificial intelligence to genetic engineering and even space exploration. It fosters a culture of curiosity and innovation, encouraging us to dream bigger and reach further. Science fiction can also serve as a cautionary tale, warning us of potential pitfalls and ethical dilemmas that advancements in science and technology may bring. It encourages us to think critically about the implications of our actions and the world we are creating. In essence, science fiction is a powerful tool for shaping our understanding of the world and our place within it. It fuels our collective imagination, inspiring scientists, engineers, and inventors to transform the impossible into reality. That's the beauty of science fiction. It's not just about escaping to distant galaxies or encountering alien civilizations. It's about envisioning a future that's within our grasp. In our imaginations, we've already explored distant galaxies and met alien civilizations. Perhaps reality will catch up soon. What wonders might the universe hold that we have yet to discover? It's a question that tickles the neurons of our minds and fuels our insatiable curiosity. As we journey deeper into the cosmos, we find that there's so much more that remains unseen and unexplored. Let's talk about something that is everywhere yet nowhere: dark matter. It's an elusive substance that we can't see or touch, but we know it exists because of the gravitational effects it has on galaxies. It's a bit like the wind. We can't see it, but we can observe its effect on the world around us. Dark matter is like the invisible puppeteer, pulling the strings of the universe in a cosmic ballet. Then there's dark energy, the mysterious force that's causing the universe to expand at an accelerated rate. It's like blowing up a balloon, but instead of you providing the puff, there's an unseen force doing the work. Dark energy is the cosmic inflator, the unseen power behind the universe's ever-expanding size. But the mysteries don't stop there. Picture this. Our universe could be just one of many. The possibility of multiverses suggests that there could be an infinite number of universes existing parallel to ours. It's as if we're living in a cosmic apartment complex, with each universe occupying a different unit, each with its own laws of physics and reality. These concepts may seem mind-boggling, and rightfully so. The cosmos is vast and complicated, filled with enigmas that we are only beginning to unravel. But with every new discovery, we inch closer to understanding the true nature of the universe and our place within it. The universe, it seems, still has many secrets to reveal. As we continue to gaze upon the cosmos, we keep asking, what's next? And with every question we ask, we take one small step further into the unseen cosmos, driven by our curiosity and our quest for knowledge.